Hello everyone, hope you're all doing well and welcome back to our physics class. It is me, Mr. Idris, a physics teacher. So before we get started, I would like to quick reminder to all of you to subscribe to my YouTube channel and hit the red button. And don't forget to click the bell to notify every time when I upload the new lessons. Okay, so before starting the new lesson, so I would like to give you a very important brief about the previous lessons, which is we have discussed about the tangential acceleration and centripetal acceleration. So as you know, the tangential acceleration is the instantaneous linear acceleration that produced by the changing of the speed in a circular path. For example, when the object is moving in a circular path with a varied speed. What do you mean by varied speed? It means that with non-constant speed. Okay, for example, when the object is moving in a circular path and its speed changes, speeding up or slowing down, in that case the tangential acceleration is produced, which is equal to alpha times radius. Okay, so after that we studied about the centripetal acceleration, is the acceleration that produced by changing the direction of the velocity. As you know, the velocity is a vector quantity. It has both magnitude and direction. By changing magnitude, tangential acceleration is produced. But by changing direction, the centripetal acceleration is produced. As you know, in a circular path, because the direction of the velocity is continuously changes, that is why every circular motion has centripetal acceleration. Okay, so every circular motion has centripetal acceleration, but not necessary for every circular motion to has a tangential acceleration. It depends. Okay, when the speed is constant, the object has no tangential acceleration, has only centripetal acceleration. But when the object is moving in non-uniform circular motion, what do you mean by non-uniform circular motion? It means that when the object is moving in a circular path with a varied speed, speeding up or slowing down, in that case, the object has both types of acceleration, tangential acceleration and centripetal acceleration. Okay, so let's get started the new lessons. As you know, in a previous lesson, we stopped it here. The total acceleration using the Pythagorean theorem. Why we have to using the Pythagorean theorem to finding the total acceleration between tangential acceleration and centripetal acceleration? Because these two accelerations are perpendicular to each other. For non-uniform acceleration, how can you determine the total acceleration? The total acceleration in non-uniform circular motion is equal to AC square plus AT square. This equation can be used to find what? Total acceleration for what? For non-uniform circular motion. Okay? Motion. Sorry. But for for uniform circular motion, A total is equal to AC. So when does total acceleration is equal to centripetal acceleration only? For what? For uniform circular motion. Why? Because AT is equal to 0 for uniform circular motion. So and the tangential acceleration, which is directed tangent to the object's path in a circular motion, and the centripetal acceleration is always toward the center of the circle. So that is why we call it centripetal acceleration. Why we call it centripetal acceleration? Because the direction of the centripetal acceleration is always directed toward the center of the circular path, which is perpendicular to the tangential acceleration. As you know, according to the Pythagorean theorem, okay, if we draw this figure here, so what is this? This is AC, okay, and this is AT, okay, and for example, if we have circular path, okay, so how can you determine this angle? And the total acceleration is located here. How can you determine the total acceleration and the direction of the total acceleration, which is the angle angle between the total acceleration and the tangential acceleration. As you know, according to the Pythagorean theorem, okay, A total is equal to what? Adjacent square, okay, plus, sorry, adjacent square plus opposite. What is opposite here? This is AC, because we can move the vectors parallel to themselves, okay? What we have in the opposite? Centripetal acceleration. In the adjacent, we have tangential acceleration. So that is why A total is equal to what? Opposite square plus adjacent square. To find the angle, as you know, according to the Pythagorean theorem, is equal to what? Opposite over adjacent. Okay? What we have in the opposite of this angle? We have AC divided by what? Adjacent? AT. Okay? Divided by AT. So in this way, we can find the angle of the total acceleration. Okay? So what is the angle between AT and AC? Is always perpendicular between AC and AT. Okay? Well, so we have some notes about the total acceleration. If V initial is equal to V final, which is constant speed, which means that the speed doesn't change, uniform circular motion. In this type of the motion, the object only has centripetal acceleration. Why? Because in a circular path, the direction of the velocity changes always or continuously. That is why the object has only AC, and A total is equal to what? Is equal to AC. If V initial is not equal to V final in a circular path, which means that the object has a non-uniform circular motion. In this type of motion, the object has both AC and AT, because the magnitude and the direction of the velocity changes. When an object is moving in a circular path, it always has centripetal acceleration, because its direction is continuously changing. But when an object is moving with constant speed in a circular path, it is tangential acceleration 0, and it has only centripetal acceleration. We have a question here. Is it possible for a car, when it is moving on a circular path at constant speed, even to have an acceleration? Yes, of course. For example, when a car is moving at constant speed in a circular path, this car has centripetal acceleration, but not tangential acceleration. Why? Because the car has constant speed. Okay, so the answer is yes, because the direction of the speed always changes and the car undergoes a centripetal acceleration. Question 9, a very good question, and it has been brought in the Wizari exam. Correct the following statement. What is wrong here? The racing car rounds the turn at a constant velocity. Racing car rounds the turn at what? Constant velocity. Is it possible to say an object is moving in a circular path or round with constant velocity? No, this is impossible. Why? Because the velocity is a vector quantity, as I mentioned in a previous lesson. It has both magnitude and direction. So that is why in a circular path, the direction of the object changes. That is why the object has not constant velocity. But we can say the object has constant speed instead of velocity. Okay? When does the object has constant velocity? When the object's direction and magnitude of the speed doesn't change. When both magnitude and direction doesn't change, in that case, only in that case, we can say the object has constant velocity. Okay? So if you correct this statement, you have to say constant speed, not constant velocity. Okay? Be careful and pay attention. Question 10, describe the path of a moving body whose acceleration is constant in a magnitude at all times and it is perpendicular to the velocity. Describe what? A path of a moving body whose acceleration is what? Is constant. Okay? In magnitude. And at all constant in magnitude, not in direction. Okay? Which is centripetal acceleration. And at all times, and it's perpendicular to the velocity. Which type of acceleration is perpendicular to the velocity? Let's draw the figure. For example, this object has tangential speed. What is this? This is V. And the object has Centripetal acceleration. What is the angle between velocity and the centripetal acceleration? Is perpendicular, 90 degree. So what is this path? This path is a circular path. So the path is what? Moving a body is a circular. The path of a moving body is circular path. How did you know this is circular path? Because the question said the acceleration is constant in magnitude, which is AC, okay? At all times, and it is perpendicular to the velocity. Which acceleration is perpendicular to the velocity? Tangential acceleration or centripetal acceleration? Absolutely, centripetal acceleration. Be careful. What about the tangential acceleration? The tangential acceleration is parallel to the direction of the tangential speed. It has 0 degree in the case of speeding up, and it has 180 degree in the case of slowing down. Question 11. An object moves in a circular path with a constant speed. With constant what? Speed. In which path? Circular path. Is it possible to write constant velocity? Never. No. Why? Because in circular path, velocity is not constant. Velocity changes through the changing its direction. Is the object's velocity constant? No. The velocity doesn't constant. Even the speed is constant because velocity has both magnitude and direction. Because its direction is changing. B, is its acceleration constant? No, the acceleration also is not constant because the direction of the AC is changing, not magnitude. The direction changing, however, the tangent acceleration is constant, but the centripetal acceleration is not constant. The tangential acceleration is constant is equal to 0. Why? Because it is constant speed. When you see constant speed, AT0 for circular path, but AC is not equal to 0 because direction of the centripetal acceleration is changes. Okay? How? Because in a circular path, when the object moving so at this point, as you know, this is tangential speed directed or pointed in this direction, and at this point pointed into downward. So here to the right, here to the upward. This is tangential speed. If the object has various speed, the object has also tangential acceleration. But be careful. The centripetal acceleration is toward the center, always. When we say the centripetal acceleration toward the center, so it means that the direction of the acceleration doesn't change? No, it doesn't mean that the direction of the acceleration doesn't change. The direction of the centripetal acceleration continuously changing. Why? So it's right, they directed toward the center. But at this point, if you extend this direction of the centripetal acceleration is directed to where? To west. At this point, where is the direction of the centripetal acceleration? Downward, south. At this point, where is the direction of the centripetal acceleration? To the east. Okay? At this point, where is the direction of the centripetal acceleration? North. So, it means that the direction of the centripetal acceleration changes during the circular motion? Yes, of course. So, is it possible to say the centripetal acceleration is constant? Never. The centripetal acceleration in a circular path is not constant because its direction changes. Okay? Question 12 from chapter review. Give an example of a situation in which an automobile driver can have centripetal acceleration but not tangential acceleration. When does we have centripetal acceleration but not tangential acceleration? In which path? In the case when the car is moving, okay, in a circular path with constant speed. Don't say constant velocity, please. When does the object have centripetal acceleration but not tangential acceleration? When the speed of the car doesn't change or at constant speed. For example, 2 meters per second here and 2 meters per second also. 2 meters per second. As you can see, The speed doesn't change. The speed is constant. So that is why the object has only AC. The object has only what? Centripetal acceleration. A car driving in a circular path with constant speed, not constant velocity. Question 13. Can a car move around the circular racetrack so that the car has tangential but not centripetal acceleration? Is it possible for an object or for a car moving in a circular path with tangential acceleration but no centripetal acceleration? No, this is impossible. We don't have this case because every circular path requires a centripetal acceleration. So the answer is no, because the centripetal acceleration is necessary for the circular motion because of changing velocity's direction. Okay? Question 14. This is a very good question and it has been brought in the Wizari exam many times. Be careful. So the gas pedal of the car, when that is used to speeding up the car, the gas pedal can be used to what? To speeding up the car. When by using the gas pedal or by pressing the gas pedal, what happened to the car's speed or car's velocity? It becomes speeding up. Okay? And the brakes of the car are used to change the velocity. As I mentioned, the gas pedal, it goes to speeding up, but the brake, it goes to slowing down. Okay, so by changing both the gas pedal and the brakes, we can change the velocity. And by the accelerating the car or decelerating, accelerating by the pedal gas and decelerating by the brake. Okay, but which type of acceleration is produced by the gas pedal and brake? The tangential acceleration. Why? Because by using the gas pedal and the brake, we can speeding up and slowing down the speed of the object, not direction. Okay, we cannot change the direction by gas pedal. We cannot change the direction by brake. Okay, so that is why by using gas pedal and brake, we can produce the tangential acceleration, or tangential acceleration is produced as a result of the gas pedal and the brake. Okay, the question is here, started here. Could a steering of the car, okay, the steering wheel perform either of these two actions? Okay, so by steering, can we produce the acceleration? Yes, of course. Why? Because by steering wheel of the car, we can turn to left, turn to right, and we can move into the circular path. Okay, by using the steering wheel, we can change the direction of the object. Okay, when the direction of the object changes, the object experiences the centripetal acceleration if the object is moving in a circular path. So it means that which of the following can cause to the acceleration? Gas pedal, brake, or steering wheel? All of them. All of them. By using all of them, we can produce the acceleration. By using which of the following we can produce the tangential acceleration? Gas pedal, brake, steering wheel, both gas pedal and brake. The correct answer is the last choice, both brakes and the gas pedal. Another question. By using which of the following, or which of the following is responsible for producing the centripetal acceleration? Centripetal acceleration. Gas pedal, brake, steering wheel, all of them. Only the steering wheel. Only the steering wheel responsible for centripetal acceleration. Okay? And the gas pedal and the brakes responsible for the tangential acceleration. Pay attention, this question is very important. So the answer is yes. The steering wheel also can change the velocity through the changing of the direction of the movement. Okay? So I wrote a note here. The gas pedal and the brakes of car can produce what? Acceleration or tangential acceleration. But steering wheel can produce what? Centripetal acceleration. Okay? Another question. Question 18 from chapter review. Why does the water remain in the pail that's reeled in a vertical path as shown in this figure? Actually, the answer should be in detail, okay, but it didn't describe it in detail in our book, so I'm going to tell you in detail about the answer of this question. So why the water remain in the pail even reeled in a vertical path? As you can see in this figure, okay? For example, if you have a pail of water and reeled in a circular path, the water remaining in the pail even in the case where the pail becomes upside down. What is the reason? Actually, the reason is because of the inertia and the acceleration. Because the pail and the water have the same acceleration, okay? They have what? They have the same acceleration, and the inertia pushes the pail into the direction of the tangent of the circular path, okay? So that is why the water remains into the pail, okay? If the pail isn't reeled fast enough, the centripetal force won't be strong, and it won't be strong enough to overcome the gravity, and the water may splash out, okay? So that is why the pail, it should be reeled fast and fast to keep the water inside it, even in the case where the pail becomes upside down, okay? So what is the answer? Because the pail and the water, they have the same acceleration, okay? Look at this sample problem 1G in section 2. A test car moves at constant speed, which is this car has only centripetal acceleration if it is moving in a circular path. Around what? Circular track. If the car is 42 meters from the track's center and has a centripetal acceleration, what is this 42 meters? This is the distance from the axis of rotation, or this is R, is equal to 48.2 meter, okay? Which means that, for example, when the car, okay, is moving in this circular path, okay, the radius of this circular track is equal to 48.2 meter. The car has centripetal acceleration and its magnitude is equal to what? AC was given 8.05 meter per second square. AC and AT, both of them measured in what? Meter per second square. But alpha measured in what? Rad per second square. So the recognizing of the units is very important for the students, because you can recognize all physical quantity by the units, okay? What is the tangential speed? What is unknown? Tangential speed. Because the car is moving in a circular path, the car has both tangential speed and centripetal acceleration in that case. According to the equation of the centripetal acceleration, AC, which is equal to what? Vt squared over R. Okay, this is the main equation. How can you determine Vt squared? You have to rearrange the equation. Cross product. 1 times Vt squared. Vt squared is equal to AC times R, ACR. Take the square root. Multiply both sides by the square root. Why? Because the unknown is not square tangential speed. The question asks it to find out what is the tangential speed. Okay? Not the square tangential speed. But here we have what? We have this square. How can you remove this square? Multiply both sides by radical or square root. It becomes what? Vt squared AC times R. Square with the radical cancel. What is remain? Vt is equal to AC times R, which is equal to 805 times 48.2. Vt is equal to 19.7 meter per second. What is this? This is the tangential speed of this car when it is moving in a circular path. So, do we have tangential acceleration in this question? No. Tangential acceleration is equal to 0. Why? Constant speed. Because at constant speed, AT is 0. Question 1. Look at question 1. In practice 1G, a race car moves along a circular track at an angular speed. What is this? This is angular speed, which is equal to 0.512 rad per second. Omega is given 0.512 rad per second. Okay? If the car's centripetal acceleration is 15.4 meter per second square, if the centripetal acceleration is equal to what? 15.4 meter per second square. Okay? And what is the distance between the car and the center of the track? What is this? The distance of the car and the center of the track. Okay? So in this question, because the omega is given, we have to use this equation. As you know, AC is equal to what? VT squared over R. Okay? And VT is equal to what? VT is equal to omega R. What about VT squared is equal to omega squared R squared? Okay? And instead of VT, write down what? AC. And instead of VT, write down omega squared R squared over R. Okay? So R with R cancel. What is remain? What is remain? Omega squared R. Now we can replace and plug into this equation to find the to find what? R. Okay? You have to rearrange this equation to find R. The omega squared goes to the denominator and AC is remain at the numerator. Replace. Do we have AC? Yes, was given 15.4 divided by omega also was given 0.512 squared. Don't forget this square, please, which is equal to what? This distance from the car to the axis of this track is equal to 58.7 meter. Is equal to what? 58.7 meter. Okay? If you have about time here, you can only use AC is equal to omega squared R. But so you have to understand, so where does this equation came? This equation came from the main equation of the centripetal acceleration. Okay? Question 2. Okay? So as I promised you, I'm gonna record the entire chapters of the physics book for the grade 12 students. Please be with me, okay? Question 2, a piece of clay sits 0.2 meter from the center of the potter's wheel. What is this? 0.2, this is a radius of the circular path, of the distance from the center to the piece of the clay, okay? The piece of the clay sits on 0.2 meter from what? The center of the potter's wheel. Okay? For example, if the clay is located here, okay, and its distance from the axis of rotation is 0.2 meter. What is this? R 0.2 meter. If the potter spins, it means that it has angular speed. The wheel at an angular speed is 20.5 rad per second. Omega is equal to what? 20.5 rad per second. What is the magnitude of the centripetal acceleration of the piece of the clay on the wheel? So, what is unknown? AC is unknown. For what? For the piece of clay, not for the wheel, okay? Because the wheel has no centripetal acceleration. Be careful. The wheel has no centripetal acceleration. The rotating object has no circular motion. Sorry, has no centripetal acceleration. Okay? For example, the people standing on the earth or any object on the earth, they have a centripetal acceleration. Why? Because every point on the rotating object has centripetal acceleration, not the rotating object itself. Okay? For example, is the rotating Earth, or Earth has centripetal acceleration? Earth has no centripetal acceleration. The object is on the Earth has centripetal acceleration, because rotating object has no centripetal acceleration. So the wheel has no centripetal acceleration. That is why the clay is mentioned in this question, and we have to find the centripetal acceleration of the clay. Okay, this is such as the previous question, which is AC is equal to what? Omega square R. AC omega was given 20.5 square times distance from the axis of rotation was given, which is equal to what? 84 meter per second square. This is the SI unit of the centripetal acceleration. Okay, the questions are very easy, and it has been brought in the Wizario exam. Be careful. Okay, question 16. A building superintendent twirls a set of the keys in a circle at the end of the chord. Okay, so the keys have a centripetal acceleration 145 meter per second square. What is this? This is AC. 145 meter per second square was given. And the chord has a length 0. The length in this case represents for the radius 0.34 meter. Okay. What is the tangential speed of the keys? What is unknown? Tangential speed Vt is unknown. AC is equal to what? Vt square over R. Vt square is equal to what? AC times R. Take the square root. Vt is equal to what? AC times R, and the radical, which is equal to 7.02 meter per second. Okay, so we finished the section 2 in chapter 1. Thanks for God. And now we're going to solve the questions from the section review of section 2. Find the tangential speed of a ball swinging at constant angular speed. Find what? Tangential speed, Vt. Okay, which is equal to what? Omega R. What is this 5? This is omega. How did you know? Because it's mentioned in the question, and also because of the unit. Okay, and the radius also is given is 5, which is equal to 25 meter per second. Question 2, if an object has tangential acceleration 10 meter per second square, so this 10 is positive or negative? This is positive. The angular speed will do which of the following? When does angular acceleration is positive? If V final bigger than V initial, alpha is positive. Okay? Or tangential acceleration is also positive. But in the case, so V final bigger than V initial, so is this speeding up or slowing down? This is speeding up. What is this? Speeding up. So what happened? So we do which of the following? The object increase the speed or decrease or stay the same? Absolutely should be increase. The correct answer is what? Increase. But for example, if they will bring like that, the tangential acceleration is -10. In the case of negative, you have to select the decrease. Why? Because negative tangential acceleration, it means that the slowdown of the object and slowing down of the object V initial bigger than V final. The last question in the section review, question 3, physics in action. If a spinning amusement park has an angular speed, omega, which is equal to 1.2 rad per second. Be careful. In the case when angular speed is given in rev per second or rev per minute, you have to convert to rad per second. Okay, what is the centripetal acceleration of the person standing 12 meters from the center of the right? Or 12 meters. AC is unknown. AC is equal to what? Omega square R. Just replace and you can find the result. Okay. Finally, we finish section 2. Inshallah, in the next lesson, we're going to record and we will continue explaining the section 3, chapter 1, physics book for grade 12 students. Thank you for listening. Thank you for your time and hope you benefited my lesson.